Now more exercises on the limit of trigonometric functions, where the limit as x tends to 0 of sin x over x is 1, and the limit as x tends to 0 of tan x over x is also 1. And if we have coefficients, so limit as x tends to 0 of sin ax over bx is equal to a over b, and limit as x tends to 0 of tan ax over bx is equal to a over b, where x is in radians, and limit as x tends to 0 of cosine x is equal to 1 by direct substitution. Limit as x tends to infinity, x times tan 4 over x plus sine 3 over x. So now if x tends to infinity, so 1 over x tends to 0. So as x tends to infinity, 1 over x tends to 0. So limit as 1 over x tends to 0. Now we're going to multiply up and down by 1 over x. So here times 1 over x, and here down times 1 over x. So this is equal to, now the x is cancelled up, and this is equal to tan 4 over x over 1 over x. Now we're going to separate the two terms of the numerator in plus sine 3 over x over 1 over x. Still the theorem and its corollaries are applicable for 1 over x. So by the corollary, limit as x tends to 0 of tan ax over bx is equal to a over b, or coefficient of a over coefficient of b, and this is applicable if it's 1 over x. So this is equal to coefficient of x for the numerator, of coefficient of x up, which is 4. So 4, and here this is also applicable, and it's equal to coefficient of x up, which is 3, so plus 3. So it's 4 plus 3, which is 7. Number 2, find the limit as x tends to pi over 4 of sine 2x minus pi over 2, and down it's tan 4x minus pi. The angle here is an expression, but we need to divide up and down by the same angle, and we need this expression to match the angle. Here we have 2x minus pi over 2, and here the angle is 4x minus pi. In the numerator, we're going to take out 2 as a common factor, and down you're going to take out 4 as a common factor, and let's see. So limit as x tends to pi over 4 of sine, take out 2 as a common factor, so 2 times, divide each term of the angle by 2. So 2x divided by 2 to be x, minus pi over 2 divided by 2 to be pi over 4. Down it's tan. Now let's take out 4 as a common factor and divide each term of the angle by 4. So 4x divided by 4 to be x, and minus pi divided by 4 to be pi over 4. Now we have the same angle up and down with different coefficients. What we're going to do now is to move the pi over 4 to the other hand side and divide up and down by the angle, which is x minus pi over 4, and the theorem and its corollaries are still applicable if the angle is an expression. So limit as x minus pi over 4 tends to 0 of sine 2x minus pi over 4 the whole thing over x minus pi over 4 over tan 4 times x minus pi over 4, and this is, and the whole thing over pi over x minus pi over 4. By the corollary, this is equal to a. So sine, limit as x tends to 0 of sine ax over bx is equal to a over b. Of course, b is 1, so this is equal to a, which is 2. and down. Limit as x tends to 0 of tan ax over bx is equal to a over b, and b is 1, so this is equal to a, so which is equal to 4. So this is equal to 2 over 4. Now number 3. Limit as x minus pi tends to 0 of tan x over x minus pi. Remember that tan 180 plus x is equal to tan x. And 180 means pi, so tan pi plus x is equal to tan x. In the denominator, we have x minus pi, and here the angle is x minus pi. So we need this angle to be x minus pi. So what we're going to do is to subtract pi and add pi. Now this is the angle, and now we have tan of an angle plus pi. And tan of an angle plus pi is equal to tan of the angle. And the sign doesn't change. So limit as x minus pi tends to 0 of tan of tan of x minus pi plus pi, or tan of an angle plus pi, is equal to tan of the same angle. So this is equal to tan x minus pi. So down is also x minus pi, and the corollary is also applicable here. So limit as x tends to 0 of tan x over x is equal to 1. The angle here is x minus pi, so this is equal to 1. Number 4. Limit as x tends to 0 of 4 minus 4 cosine 2x over x squared. We're going to take out 4 as a common factors. So limit as x tends to 0 of 4 times. Divide each term by 4. So 1 minus cosine 2x over x squared. 1 minus cosine 2x, we can use the trigonometric identities of double angle, because we have 2x, to rewrite this expression in terms of sine x. Let's see. By the trigonometric identities of the double angle, cosine 2x is equal to 1 minus 2 sine squared x. Now, to get this form, we need 1 minus cosine 2x. So let's move the 1 to the other side. So cosine 2x minus 1 is equal to negative 2 sine squared x. Now, change the sign of both terms. So negative cosine 2x plus 1 is equal to sine squared x. We write this. So 1 minus cosine 2x is equal to 2 sine squared x. So finally, 1 minus cosine 2x, this is equal to 2 sine squared x. So we're going to substitute this by 2 sine squared x. So this is equal to limit as x tends to 0 of, we have 4 times 1 minus cosine 2x is equal to 2 sine squared x. So times 2 sine squared x over x squared. So this is equal to limit as x tends to 0 of 4 times 2. If the sign is squared and the x down is squared, so we're going to square the whole thing. So this is equal to limit as x tends to 0 of 4 times 2 times sine x over x. The whole thing is squared. So by the theorem, this is equal to 1. So 1 squared to be 1. So finally, this is equal to 4 times 2 times 1 to be 8.